Thank you. My talk is mobile application testing with Python and Selenium. My name is Jason. I'm a software developer at Sauce Labs. Here's my Twitter handle if you want to heckle me during the talk. I love it. Or if you want to ask any questions afterward and can't find me, I'll happily respond to any tweets. So first, let me start with a very brief aside. I woke up this morning and my computer wouldn't turn on. So it is entirely possible that the computer will die in the middle of this presentation. I have a backup plan, so we'll just do a quick swap and it'll be great. This is what it looked like for approximately 2 hours. And as I wandered around and told people that my computer wasn't working and I had to give a talk, there were so many people who were willing to help, and I just want to call out, PyCon is an amazing community of very kind and very helpful people, so that when you're doing a presentation and your laptop dies, they will take care of you. But specifically, Augie Fackler, Terry Peppers, and Jonathan Lips, thank you very much for getting things together for me. Yeah. So like I said, I'm going to talk about Selenium and Python, and I'm pretty sure that everybody here knows the Python part, so let's go ahead and talk about Selenium. What is Selenium? Selenium is an open source library for automating browsers, and when I say library, what I mean by that is you can incorporate it into your unit tests, into your automation scripts. You can use it for basically any time you need to automate a browser. So next year, when you want to try to score Google I/O tickets, you just write a Selenium script and make it do it for you. And so the key point here is this is a tool just like any other. This one just automates browsers. And the goal of the Selenium project is to provide coverage for every browser on every platform. And they do a pretty good job of this. There's Windows, Mac, Linux, Android, iPhone, even some experimental platforms like BlackBerry. I know, it's funny. And when you first dig into Selenium, you're going to be really confused because there's actually two versions of Selenium. There's Selenium RC, or what we call Selenium 1. This used JavaScript to drive the browser. It didn't really have any OS level integration. But what's important for us here in this talk is that there are no mobile implementations in Selenium 1, and it's deprecated. So you don't want to use Selenium RC. If you're new to Selenium tests, you don't want that. You want the new hotness, which is Selenium WebDriver. And WebDriver integrates with the operating system to simulate OS level events to drive the browser. So when you click, the better WebDriver drivers actually simulate an OS click, which is really cool. But what's really pertinent to us is that there are iOS and Android drivers available for WebDriver, so you can automate mobile phones. Specifically, you can kind of automate mobile phones. So here's how WebDriver works. You write a script. You can write that script in whatever testing framework you want, so it's Python, it's probably going to be a unit test. And then that is going to call into the Selenium library, which sends commands to a Selenium server. And that Selenium server is either running in a browser, like Firefox has a Selenium server in it, or Android and iPhone drivers, they're apps that have Selenium servers in them. Then the Selenium server calls into the browser, which actually navigates to your app that you're testing and makes it do all of the things you want it to do, and then returns the response all the way back to your script, so you can decide, hey, did this do what I wanted it to do? And this is what a test might look like. So very simple, from Selenium, import WebDriver. Let's create a driver. In this case, it's going to be a Firefox. Let's tell it to wait up to 30 seconds for any asynchronous stuff or elements to appear on the page. Yeah, 10 minutes with this Wi-Fi. Then we're going to navigate to pycon.org, and then we're going to close the browser. So here's where I get brave. So this script is similar to the one I just showed you. Hopefully it works. If it doesn't really matter. What it's going to do is go to the PyCon page. It's going to find an element, in this case the events link, click on it, click on the conference talk schedule, click on my talk, go to my page, and verify that we made it there. And again, what's going on under the hood here is basically a series of RPC requests. It's asking the browser to do something and then blocking on a response. And the browser, as you can see, is automated, clicks on things, does things, and returns responses to the script so that it knows that it successfully completed each of the tasks that it asked it to do. And what's really cool about this is that this is a standard that's being proposed by W3C to be incorporated into all browsers. So in the future, there won't be this need to have a Selenium server. You'll just have it built into all of your browsers by default, which is really great. So there you go. It worked. So it's worth applauding. Thank you, PyCon. The Wi-Fi didn't die. Okay, so let's get mobile. So we just saw a test. it was not mobile. And we want to write mobile tests. That's a good thing, especially with the move towards responsive design. You have different CSS that's being executed in different devices and platforms. You need to have mobile tests. So the goal here is, let's write the test once, let's make it robust, and let's run it in a different browser. And if that worked, this would be a beautiful world. But it really doesn't work that way. It's close. It's very tricky. And the reason it's tricky is very complicated. So let's dig into it. Every mobile browser is what's called a remote WebDriver. So instead of talking to a browser on my computer, I can send those WebDriver requests, they're just JSON. I can send them over the internet to a remote WebDriver instance, living on another computer, living in the cloud. Well, the mobile browsers act that way even when you run them locally. You send your request to a port on your local host, and you remotely drive a browser. So let's look at some code that illustrates how this looks. Remember this. This is the test that I just ran. Here's what I would have to do to that test to make it run on an iPhone. It's a lot more complicated. That one line, driver equals webdriver.firefox, just became a mess of code. But it's really not that complicated. You just need to understand what's going on. So look at the bottom line. Driver equals webdriver.remote. I'm passing in a URL, and I'm passing in this desired capabilities object. So what does that do? Well, the URL is where it's supposed to send the commands. And the desired capabilities talks about what kind of browser you want. So in this case, I want an iPhone. Mac is the placeholder string that says make it an iPhone. And I want version 6.1. If I wanted an Android device, I would do this. I would say the browser should be Android. The platform is Linux. Give me 4.2. And because Android runs on port 8080 while the iOS driver runs on 3001, I adjusted the port. So let's talk about iOS WebDriver a little bit. You can only run it on a Mac, requires Xcode, and it's a .app that you build and run in the simulator. There's some huge limitations to this. It can't handle frames. It can't handle alerts. It actually can't quit. There's no way to clear the cookies or cache on the device except to do it manually. So, but it's better than nothing. So let's take a look at it. So the first thing we have to do is go into Xcode and run the project. And what it's doing is building the app, launching it in the iPhone simulator. We're done. So you can see at the bottom it says it started it, and it's running on port 3001. So what I'm doing here is running a test against the iOS simulator on my computer. Now, again, the Wi-Fi here is flaky. This may or may not work. But yeah, there you go. So the premise is the same. This is exactly the same code that I ran in Firefox, but now it's running in iOS on the iPhone driver. And it could go on for a while. I'm not going to sit here and belabor the point. I think that the point is well taken. So I'm just going to kill that. OK. So now that we also have the Android WebDriver, this is a whole nother animal. The Android WebDriver requires the Android SDK, and it builds an APK that you can run in the Android emulator. And setup is super hard, very, very annoying. And the reason is you have Android running in a virtualized environment, and you need to make a connection between that virtualized environment, your local host, and your tests. So there's a lot more setup that has to happen. And the emulator's pretty slow. It takes about 2.5 minutes to boot up the first time, and subsequent boots are all over the place. So let's talk about the setup steps. You install the Android SDK, you have to create an Android virtual device, you have to launch the Android virtual device, you have to use the Android debugger bridge to connect to the device, install the app, start the app, and forward the ports that you're going to use. It's a lot of work. So I'm going to do it, naturally. So I've already got my emulator running, as you can see. I did not want to make you sit here for 2 minutes and watch it boot. And the first thing I have to do is kill and start the server that connects to the Android emulator. So yay, that worked. I've already got the app installed, so what I'm going to do is I'm going to forward the port that I want to use. So I didn't want to type in front of everybody, so I just copied some commands. So the first thing I did is I forwarded port 8080 on my local host to the emulator. Now I'm going to run this big, long command, and what this does is it starts the WebDriver. So there, you can see, WebDriver ready. Excellent. Let's run a test. And you can see it connected. It is now trying to get the internet, and it's failing very hard. There we go. And this test is going to fail, by the way. And it's going to fail because the WebDriver implementation of click does not hold the mouse button down over the events in Android. So when it clicks events, you'll see it blip very quickly. The events menu will appear and then disappear in a split second. I'm not going to wait. So let's talk about some of the problems with these. Both of these drivers are what we call web views. That means that they are a window to the internet that's provided by Apple or Android for you to put in your apps. So these aren't real browsers. They're not first-class citizens. They're an implementation that may or may not be maintained the same way the browser's maintained, and usually uses some sort of slower rendering and JavaScript engines to drive these. It's really hard to do tests with these on real devices, and it's hard to get accurate behaviors out of these drivers. And each mobile implementation is a little bit different because they can't use exactly the same JavaScript to drive them that they use for other things. So that's Selenium testing on mobile apps as it is now. I'm going to come back to this again at the end of my talk. So let's move on, though, and talk about native app testing. Native app testing is really cool. It's something that's kind of nascent, and not a whole lot of people are doing it. So if you're working on an iOS app and you want to test, right now your only option is UI automation. And UI automation is a big problem. Here's why. You have to write your UI automation tests in JavaScript. And you have to upload those tests all at once to the instruments test runner, which then will not let you talk to your tests or do any introspection in those tests. For example, they can't get out to the file system or do any of those things that you might want them to do. They have very limited command line control, which makes it very, very difficult to put these into CI. And at the end of the day, the biggest issue is unlike the example I just showed where you can write one test and run it in many browsers and devices, there's no test interoperability with instruments. Android really isn't much better. In the Android situation, you have UI Automator, which are Java tests that are compiled into a jar and pushed to the app. Pushed to the device, and then they're executed against your app, and JUnit comes back. So again, a lot of the same problems are here. It's not real time, it's not a remote control, you can't interact with the tests, and again, you're writing tests just for this Android app. There's no interoperability. So if you, for example, wrote an iOS and Android app using a cross-platform framework, you would have to write tests twice, even though you're using the same framework on both platforms. There's some alternatives to these officially supported frameworks. These fall prey to the same four things. They either require you to recompile your app and add third-party code that you don't really know anything about and may or may not be tested. They have a mixed bag of APIs. Some of the APIs are good, some of them are bad, but they're all different. They have a very limited community. Some of these testing tools are kind of dropped out in the real world as open source but not supported software, and so the community isn't there to support you using these frameworks. And then the last thing, and kind of in a way the worst, is that a lot of these are forced language implementations. So you might be able to find a tool that lets you write iOS app tests, but it's going to make you write them in Ruby, which none of us want to do. So we think, and by we I mean the Appium project, think that this is actually really bad and that this should change. And it all comes back to test reuse. You want to write your tests once. You want to write them in a way that they can run on all of your platforms and all of your devices that use the same app. And you want to write them against a standard API that you already know, using tools that you already know, and a test framework that you already know. And you can't do that with any of the tools that exist now. And so the solution is this project called Appium. And what Appium is, the easiest way to think of it is it's Selenium for native apps. It provides a Selenium API, which we already looked at, and lets you drive native apps. So a couple features. There's no recompilation of the app required. So you can run Appium tests against the exact same binary that you're going to put into the App Store, which is really nice. It uses the Selenium API, which is already supported in Python, so you can use a Python client library to run Appium, the same exact one you use to run Selenium tests. So there's no extra dependency required. And all the methods in Appium are first-class citizens. And what I mean by that is we wrap the native test frameworks that these companies are telling you to use. So we take UI automation and we wrap it, and we return Selenium responses from UI automation. And that's what gets a lot of the benefit out of this, is that's in that standard API. You can do this with any language. I say any OS, that's still a work in progress, that's a goal. But you can use basically any test framework that supports Selenium right now. And it's open source with a very active community of people who are contributing. So here's how it works. Appium on iOS wraps UI automation and instruments. So instead of your script talking to a Selenium server, it talks to an Appium server, which talks to Apple's instruments. And from instruments, it sends commands in and out of your test app. And what we've done is we've bootstrapped instruments so that it can receive additional commands. So instead of having to upload all of your tests at once, you can send them one command at a time, just like you do with Selenium. So I want to demo an app for you called Everest and show you how this works. So the first thing we have to do is start the Appium server. I have a convenience thing here that's going to do it for me on port 4729. And then I'm just going to run this iPhone demo. Let me see if I have my simulator up. Yeah. So what it's going to do here is grab the app, upload it to the emulator, although it could be a real device. And now it's sending commands one at a time and getting responses. So we're sending swipe commands, and now tapping, logging in, typing on the keyboard. All of these things are handled with native iOS methods that are being called by Apple's preferred testing tool, and we're calling using Selenium. And it's really cool. I actually do sometimes just launch this to watch it. Get a jetpack. Anyway, as loath as I am to leave this, let's go back to the talk. By the way, Everest is a really cool app. Go check it out. So Appium also works on Android, and it works the exact same way. The under the hood implementation is different, but to the user, it's the same. You write your tests in Selenium, and if you're using a cross-platform mobile framework, you write one test, and it'll run on iPhone and Android. Your test talks to the Appium server. Appium sends commands in and out of UI Automator, which is Android's solution. It's funny, those have such similar names. And then that's going to talk to your test app, and that's it. We've bootstrapped UI Automator to be a Selenium server, and it just works. And I also have a demo for that using a different app. And because the internet's so bad, please forgive me, I'm going to actually show a recording of that test. Oh gosh, what did I do? This is the one I want. All right, so what's happening here, and it does take a second to get going because it's compiling that jar that I talked about to upload to test, but in that jar is just a bootstrap server that makes it start listening for commands to be sent. And then it's pushing a fresh copy of the app up to the Android emulator. So in a second, we're going to see it launch, and it's going to start doing automation. There it goes. So again, we're doing the exact same thing we did on iPhone here, just a different app. We can send keyboard commands. We can find elements. We can tap on things. We can scroll. And all of these commands are being sent in real time. So if I signed up for a new account, one of the things I could do here that I couldn't do using the old framework is sign up for an account, and then using my Python script, go check my database to make sure that the account showed up. And you can't do that using the original, the UI Automator framework, but you can do that by wrapping it like this with Appium. And again, this is so cool to watch. It's remote controlling an app, which is awesome. So as much as I hate to cut that short, got to keep going. So what's next? Well, you can drive the browser with Appium as well. And I'm going to talk about this really quick. This is a work in progress. We're still working on it. Instead of just wrapping the native UI automation commands, we've also wrapped the WebKit remote debugging protocol, which means you can connect to any running WebKit instance and remote control it. So why do we want to do this? Well, we want to drive a real browser, not some second-class browser that Apple's provided, or Google. We want to have actual rendering engines and see what our mobile apps are really going to look like in the browser. We want it to be accurate. We want it to work on real devices. And we want it to be standards-driven. I have 2 notes here. We want W3C compliant browsers whenever possible, and we want them to be browsers that are trying to implement the WebDriver protocol. Now, I don't know if Apple's going to do that, but if they do it, they're not going to do it for the UI web views. They're going to do it for mobile Safari. So we should be automating mobile Safari. And then I talk about the atoms here briefly. What the atoms are is they're snippets of JavaScript code that the Selenium project has distilled that are standard and run in any browser that has a JavaScript engine. And what those do is they provide consistent automation across a wide variety of browsers. And what we can do with the remote debugging protocol is inject these atoms into the DOM and execute them, which means that when we say click, it's the same click that happens on Firefox or the same click that happens on Google Chrome. So that's really cool. So again, let's look at a demo. Again, I'm going to show a video of this. This all does work. I'm not trying to avoid it, but the internet here is fairly slow. So what we're doing here is launching mobile Safari, and I racked my brain last night. What company is using Python and has responsive CSS? And the answer was Disney. I'm sure they don't drive their website with Python. But so here we loaded the Disney page. We're scrolling a bunch. We found something interesting, so we're going to swipe through some of these Disney characters. And once we get sick of that, we're going to go up to the top. And it dawned on me, like here I am giving a talk at PyCon. What am I going to do when I'm done? I'm going to go to Disneyland. So that's automating the browser. And it's really cool. Android is still a work in progress, but iPhone's working, and it looks great. And it's the only way that you can automate mobile Safari, so it's really cool. So that is all I have. Thank you very much. If you're interested in the source code, please check it out at github.com. And you can follow Appium Devs on Twitter.
If you have a question, please line up behind the microphone over there. We have about 8 minutes or so.
Hi. So I have a situation where I'm offering a client's using a third-party app. It's an Android app, as it happens. And then when the data comes up, we have our own web app that we're doing all kinds of stuff with. So I'm wondering if is it possible to use Source Labs to test? And we don't want to be running Android and blah 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 and doing all that locally. Like just install a third-party app on one of your Android instances and then use all this, because we use Selenium for other stuff.
Yeah, that's a great question. So the question was, can you use Sauce Labs to run native app tests in the cloud? And I think your question is specifically about Android.
Android or iPhone, and apps that we don't own, like apps that we're just pulling from anywhere else.
Oh, just third-party apps?
Yeah.
Right. So you can put any app you can get your hands on the source for, or a compiled version of. So I didn't write the Everest app. They sent me a .app file, and yeah, you can put those in our cloud. Android isn't ready yet, but iPhone tests, there's some people using. It's a beta program, so we're working on getting that in the cloud because we don't think people should have to maintain all of this nonsense. It's really hard.
Thanks.
So you used emulators and simulators. Do you have that on actual devices? Does that work?
People have run it on actual devices. It does work.
Okay.
That's because UI Automator and UI Automation work with real devices. So, yeah.
Okay, great.
That was my question.
I have a Mac application. It has its own web view. Can I use Selenium to test a website opened by the web view?
So the question is, if you have an application that has a web view in it, can you use Selenium to test the web view?
Yes.
There's 2 different things you can do. One is you can use the apps that I showed off, the iWebDriver and Android WebDriver apps, and you can load the web view without the native frame on it and test it like that. The other thing you can do is, Appium has a hybrid mode where you can use native UI automation commands to drive the native parts of the app, and then when you load your UI web view, you can switch to using the remote debugging protocol and automate that directly, and that's really, really cool.
Actually, I'm not referring to UI web view. That is NS web view.
Okay, sure. It will still work.
My question is related to the previous question about the devices. So with Android, we usually need to test on many devices and fragmentation, etc., etc. Does it work on all the version, also in older versions, or is it just a 4.2?
So UI Automator is a API level 17, 4.2 only framework. However, we are hoping to incorporate the Android instrumentation framework so that we can support older versions. It'll probably be a subset of commands, and most of the dev effort will be put into things moving forward, but we do hope to support more than just 4.2. But as of today, it's 4.2 only.
Okay, thank you.
Hi, at my company, we're using Calabash right now.
Sure.
And I'm writing a Python interface for it, but this obviously looks like it kind of kicks its ass. Could you compare the different features? I know it has like pinch to zoom and stuff like that, but
Yeah.
obviously one of the benefits is not having to recompile the iOS app.
So the question was, how does this compare to Calabash, which is one of the tools that I was hinting at when I had my alternative slide. And the answer is, when you're running an Appium test, you don't have to recompile your app. With Calabash, you do. That right there is a deal breaker for me. But the other thing is, since we support the Selenium bindings, and we're implementing all of the Selenium bindings, we actually have a slight superset. We've implemented some execute script commands that you can use to do very specific mobile implementations, like controlling sliders or picker wheels or all of those types of things. So the short answer to your question is the Selenium API is very broad and extremely comprehensive and very flexible because of the way that they use the action chains. I actually wrote the touch actions patch for the Selenium bindings in Python. And it's basically just a set of fundamental movements like tapping or holding or whatever that you string together to create your own mobile gestures. And so it's extremely flexible. So I'd be happy to talk to you about specific implementations at the Sauce Labs booth after.
Okay, thank you.
Ladies and gentlemen, Jason Carr, thank you very much.